All right, so looking at integrating functions that are sort of have a linear function inside them. So looking at the rules from the text, you can see we're looking at a very specific sort of function here. Now, these rules from the text, ideally, I'm going to show you a different method which I'd prefer you use, but I'm leaving this here if you decide to use it. So you can see that these particular ones, we've got an exponential with a linear function, we've got a linear function inside a power, we've got two trig functions with a linear function inside them, and pretty much these rules here come from our chain rule. So when we do the derivative of these, we're going to end up with this thing multiplied by a, so the 1 over a counters that as such. Now, the method I'm going to use with you is called substitution, and we will go through it. So it's like if we have the integral of a function and it's not a standard result, so this isn't one of our rules that we know, we change it into the form of g, like another function with respect to u, and u is with respect to x. So similar to how we've done substitution before, therefore we've got this function here. And then the integral of our original function is going to have some constant, and we're going to need to get our gu function that we've got with respect to u. We're going to need to get the derivative of u to x over dx. And then that's going to allow us to cancel out these dx's, and we end up with this constant times our new function, gu, with respect to u, which sometimes can mean we get a really easy integral to take. And so we then get that constant times the antiderivative of gu plus c, and then we sub back in and we get the antiderivative of our original function, but we've solved it. Now, I'm going to go through, this is example 8 from the text, so I'm going to talk through it, and then maybe I'll even scribe on here as I go. So we're given this function here, and so the idea of this method, which is called substitution, is we're going to go, well, let's use u to the power of 4 because we know how to do the integral of this. This is an easy integral. This is something we're used to doing. We've done it in the previous section. And to do that, it means we're going to change u to this 2x plus 3. Now, the derivative of u is du dx, and it's this 2 value here. So at the moment, if I sub this u, I sub u equals 2x plus 3, we end up with this u to the power of 4. So I swap out the 2x plus 3 and I get u to the 4, but it's with respect to x here, which we don't want. So we need to change it to respect to u, and this is where this derivative here comes in, is I need to have this 2 in here. Now, for me to have the 2 added into this function, I sort of need to multiply it by the constant a half. So this would mean that this half times 2 gives us 1. It's not changing anything. Now, because I've got that in there, I can now swap this 2 out for du dx, and I've got half this easy integral to do, du dx, and that then becomes half the integral of u to the power of 4 du. And we know this one, so then we get, this is going to equal a half u to the power of 5 because the integral is the antiderivative, so we go a step before it, so n plus 1, so 4 plus 1 gives us 5, and all over 5 plus c. I then sub my values back in, so 2 times 5 equals 10, and then we've got our original function, 2x plus 3, and I've made an error. Luckily, we've spotted that, to the power of 5 plus c. Now, I might have rushed through that, so let's do one together as we go. So this function here, you can consider doing it yourself if you want to try it, but I'm looking at this and I'm thinking, this here could be integral of 1 over u to the half dx, or that could be u to the negative half dx. Now, that looks like something I could take the derivative of. So what I need to consider is I need to consider how I'm going to get it to the form du dx. So I've got to find out what my derivative of du dx would be. And at the moment, we've got u equals 1 minus 3x. So the derivative of u with respect to x would just be negative 3. So what I need to do here is now I'm going to change my integral to be, because I need a negative 3 in there, I'm going to put a negative 1 over 3 outside my integral because constants can move in and out of the integral. It doesn't matter. And then I'm going to put a -3 here. So they're going to multiply together. So this times this would give me this 1 here, almost. And then I've got my u value, which is u to the -1/2, which is this bit of the function here. I've just moved it up to the top. And I've now got, with respect to x. Now, next line, I'm going to write -1/3 integral. Now, I'm going to change this -3 out, and I'm going to write this now as u to the -1/2. Instead of this 3 here, we're going to write that as du dx, and that is with respect to x still, but because we've got dx and dx, they're luckily going to cancel. So our next step here is going to be equals -1/3, and then I'll still do my integral u to the -1/2, and then that's just with respect to u. Next step, let's do the integral. So we've got our constant, -1/3 out the front. U to the 1/2 is going to give me u to the -1/2 is going to give me u to the 1/2 over 1/2, and then plus a constant. So final step here, this is going to end up being negative. Okay, remember, divide by 1/2 is the same as times by 2, so this is going to be -2 over 3. I got the negative from out here, so -1 times 2. And then I'll write it as u to the 1/2, which is just square root u plus c. Final step here is -2 over 3. Now, I'm going to resub u back in. So u was 1 minus 3x. And then plus c. And I should get in the habit of putting c as a real number. So we've done that one with substitution. This next one here, integrate with respect to x. So we've got integral of 2e to the 2x. I'm going to break this up into 2 separate ones just so we can consider our method. These dx minus integral of e to the -3x dx. So this one here, once we follow the method of one, we would see it with the other. So this one actually is going to seem a little bit easier if we had the rule ahead of us, but the issue is that we're having to remember more rules in here. So I'm looking at this and I'm going, well, if I consider e to the u, okay, u equals 2x, which means u du dx equals 2. Okay, same with this one here. I would have e to the u. I'll use v for this one just because we've got 2 here. So v would be v equals -3x, which means dv dx equals -3. So maybe I'm going to leave this negative inside. So I might just plus and negative there. So my next step here, I'm going to quickly write this integral as e. Now, this is going to be integral of e to the u, which I'm just subbing out that 2x. And then, luckily, I've already got this 2 here. So that 2 is du dx. So then I've got du dx is dx. So this little bit here, I'm just going to write plus. If I was doing this quickly, I've now got the integral of e to the u du, which is perfect because the integral of that would just be e to the u. But I've got this other little bit here, which I've got to put a -3 in here. So I'm going to write this as the integral of e. At the moment, I've got e to the v, and I'm missing my dv dx, but it's with respect to x. So in here, I'm going to need this -3. Okay, so I'm going to put a -3 in there. And to balance that out, I'm going to have to put a -1/3 at the front. So now this next line here is going to be let's get rid of that plus, negative 1 over 3 integral e to the v, and then that 3 there is dv dx over dx, which means my next line here, let's just equals, and then next line here is going to be equal eu minus 1 over 3, and that's going to be, I'm just going to skip this step. We've seen that a few times, that they sort of cancel, and I'm left with this would just be e, not u, this would be e v. I can then sub my values back in. U was up here, was 2x, so that's going to give me 2x here, minus 1 over 3 e to the v, which is negative 3x plus c. Let's find a different colour for that. Maybe that one, where's that there? And we'll quickly, I'll put that there as well. Cool. All right, that one's all done. So this method, it's going to seem longer at the start, but if you master this, you'll actually find the complex integrals significantly easier. And this, while not in the methods course, is actually like, if you're going into anything that's going to need further maths, it is worth doing this way. All right, final one, integral 2 sine 3x plus cosine 4x plus pi dx. All right, we're going to break this up into two individual ones. 2 sine 3x plus integral, I keep forgetting little bits of notation, so make sure you're more careful than I am. Integral cosine 4x plus pi dx. So this one here, I'm looking at this, I'm thinking, well, if I make u equal to 3x, then du dx equals 3. I've just got to get a 3 in there somehow. And then this one here, we'll call it v equals 4x plus pi. So dv dx equals 4. So I'm going to have to rewrite these integrals as, so I'm just going to, this first one, because I need a 3 in here, I'm going to have a third out the front. So I'm going to do 1/3 integral 2 sine 3x, and then this will be times by 3, and then dx plus our next one here. I'm going to have a quarter out the front to make way for this. So we're going to have 1/4 the integral cosine 4x plus pi dx. Oh, and then I need in here a times 4 because I added, have I got enough room? I'm going to have to shift that a little bit for us. Let's just drag that a little bit there. Cool. Okay, so then we've got times 4 in there. So now we're in the form of 1/3 integral 2 sine u, and then that is du dx, because that's what we figured out up here. And that's that 3 being swapped out, dx, and plus 1/4 integral of cosine v, and then I've got dv dx. All right, now these are easy ones to do. So I've got 1/3 times 2. The integral of sine is negative cosine, so we've got negative cosine u. I'm going to get a bit lazy here. I'm going to cross them out. They're going to cancel, so I'm with respect to u now, like I wanted to be, plus 1/4 cosine u is going to be sine u, and plus a constant, which is a real constant. So next step is to sub this all back in. So I've got 2 over 3 cosine. And then what was my u value? My u was 3x. So I'm going to put my u back in there. Now, I think I'm missing my negative sign here. So I almost missed that. So 3x plus 1/4 sine. And my u was 4x plus pi plus c. All right, that's all we need for that one there. Please try substitution, at least try it for a few examples, see if it works for you. If you need the notes here and you want to just do it with the formula where you just look at it, you can do it that way. You're going to get a deeper understanding by doing substitution. Thanks, guys.